Good morning. To-do list for today: 30 minutes Q&A and watch a review video, and then quiz analyzing function. The quiz has to be taken in class only, and then attendance after you turn in the quiz, office hour. So we'll go over domain, range, and behavior attributes of a function. First, I will go over one of the activity you did that student make quite a lot of mistake. So this one on the right, the shaded is not where the open ended. So that's what I wrote. Now, if you did this, you read the direction, you're gonna move this where the open ended. So the dotted line with the open ended circle, the solid with the solid circle. Okay, so what's the inequality for this? So we're gonna type it in here. We know if you go to the left, it's at 1 solid line. We need the equals x. And if you walk to the right and you look up, the endpoint is when you are at x equals 4. And it's open, so less than x, less than 4. Okay, you see the dotted line because it's less than, open circle, less than. Next, fix the inequality. If I go all the way to the left at negative 1.5, I look up, I see the solid. So I'm going to type negative 1.5 less than equals x, less than, to the right, open, so, and where is it at? Above x equals 1. Don't forget to click submit. So which one is the inequality for this? On the left is the solid, so I know it's either 2 or 4. And on the right is open. The last one is wrong, so it has to have the less than only, so I choose the second one. Be careful. So if I walk on this x-axis and I go to negative 5, I look down, I see the endpoint is solid. And if I walk all the way to the right at 10, I look up, I see the endpoints. So my domain is where I was standing between negative 5, less than, because it's solid, x, less than, because open, and then type in 10. Same thing here. If I go to the left, it's at negative 6. So negative 6, solid line. They're both solid. Ever see that? Both solid, less than. Ever see? I go really fast now because it's a video, right? A video. So you can pause. If I go too fast, you can pause and watch. Take notes, whatever you need. Same thing here. So this one has 2 solid lines. That means it marks 2 solid endpoints. So I'm going to drag it. This is dotted, so I have to match with the dotted and make sure my shaded cover the piecewise function. And this go to infinity, so it's dotted too, right? Open parenthesis. Next. Okay, this is a piecewise function. We need to write the domain. It's a click here, click down below. So let's start with the left. If I go to the left here, that's negative 6. Keep going, negative 3. They're both solid, so negative 6 less than equals x. All I did was do the less than and the minus sign, and it give me the equal on the bottom. Less than equals on your keyboard, your computer, Chromebook keyboard, and -5. I mean -3. There we go. Press click on the bottom to go to the next for the next interval right there. That is at -2, -1. So -2 less than only, because open circle, less than -1. Next one is 1, 2, 3. Open solid. 1 less than x less than equals 3. And that's my 3 interval for the domain. Next, we're going to talk about the range. The range is top and bottom. If you look at this, it's a parabola. How far does it go to the bottom? -infinity. How far you go to the... If I walk on the y-axis, I look left and right, I see the top, the local maximum. So that's the biggest. So we write y less than equal to 1. We include equals because it is included. When you have a max or minimum, you gotta have the equal there, okay? At the either the upper bound or the lower bound. At the top is at 2, 1. So this is local maximum. So what is the local maximum? Is 1 at x equal 2. Let's determine the range. Let's drag it. So this is everything. This is dotted. So I will put dot. And then at what? At 2, right? -2. So the range is -2 up to 3. Remember, you can pause and watch it again, whatever. This is a video. Okay, again, let's figure out the range. How far does it go to the bottom? -2, right? I need to write -2 -2 less than equals y, because the range less than 2. Look at that. Okay, we're going to do the same thing here. Let's start from the top, right here. The first, find the interval for this. So what's the smallest here? If I walk on the y-axis or climb up, it's at 5 to 6. So I'm going to write 5 less than y less than 6. Enter to go to next. Now, a lot of you make mistake. You say yes to zig. Zig is incorrect. There should be only 2 interval, because this, if you get the inequality for this, it will cover this as well. So you don't need the inequality for this. So I'm going to just need this right here. So how far does it go to the bottom? -2. -2 less than equal. Remember, this is the local minimum. This is the local minimum, guys. The quiz will ask you, what's the local minimum? You would say, it's at -2 when x equals -4. Okay, that's the local minimum. So local minimum less than equals to, how far does it go up here? How far? What's the y value here? It's 2, right? Look at this. You only need 2 because this inequality cover this range as well, represent this range as well. So you don't need 3. Some of you wrote 3. You write the range for this too, which you wrote 0 and then up to 1.5. So if you write this, then this is incorrect, okay? 0 less than y less than equal 1.5. See that? It maybe 1.4. There we go. Maybe 1.41. Doesn't matter. But you don't need this. Look at this big shaded region already covered the blue shaded region. So you do not need that. So therefore, zig is incorrect. Okay? I just explained. Only need 2 inequality. Because the shaded, the interval on the left bottom cover the inequality on the right segment of the graph. Okay, let's see here, and then that's it. This doesn't mean your is all correct or complete. You can just go here and it will tell you, so be sure to complete all of them. Okay, so next I would like to talk about function characteristics. So this right here is going to be your local minimum. So it will ask you, what is the local minimum? You said the local minimum is the y coordinate is -4 at x equal to about 1. This one right here is the local maximum. So let's say this is -1, 4. And here is about 2, -2, 2. So the local maximum is at 2 when x equals -2. Okay. Then we can talk about when is it decreasing. Decreasing is between the maximum and the minimum. That's decreasing. Okay. So we can say it's decreasing between -2 to 1. Now some of you could have corrected me. This is +1, right? So 1, 4, right? 1, 4. So we can say it's decreasing from -2, 1. And then increasing would be from here, from the local minimum up to that. And we can say it's increasing when x is 1, positive infinity. And also here is increasing right here. From left to right it rises, so it's increasing. So we can say from -infinity, -2. These are the x interval. Okay. So this is increasing, decreasing. We could also talk about positive. When is it positive? It's positive when it's above the x-axis. So everybody see this shaded region right here. This is positive, right? And this right here is positive too. And right there below it, that's negative. That's negative. That's negative. Okay. So when is it positive? We could write the interval is between, I think the x-intercept. See the x-intercept? Those are called 0. There are 3 x-intercept, right? X-intercept at -3, that's called the zeros, at -1 and 2. So there are 3 zeros, right? So you could figure out the interval, see, of all of this. If you can see that, you should be able to see it. One last thing, we would like to talk about end behaviors. How do you determine end behavior? End behavior is the errors. If you have any question, you can ask me during the Q&A in a second. So end behavior is where the error is, okay? So look at the coordinate. What's the coordinate here? This is -infinity, -infinity, right? So the end behavior is as x approaches. What is the x coordinate here? -infinity. What's the y coordinate here? -infinity. So where the arrow is, you can find its end behaviors. The same thing here. What's the x coordinate on the arrow? Positive infinity, positive infinity. So you say x approach positive infinity, y also increase without bound, right? That's another way to say it. As x increase without bound, y also increase without bound. So